Hello everyone. So today we are going to study the Newton's law and the orbit of planet. First topic is the universal law of gravitation. The second topic is the Newton's laws. And the equation of motions. We derive the conservation of energies, conservation of angular momentum, and the orbit of our bodies, and we derive the Kepler's third laws. In the last lectures, we derive the universal law of gravitation from the Kepler's laws. So in these lectures, we use Newton's laws and the universal law of gravitation to derive the Kepler's laws. This is today's lectures. So let's move to the next topics. First topics. Universal law of gravitation. In the universal law of gravitation, we consider the two objects. One of the objects has a mass of the m sub 1s, and the other object has a mass of the m sub 2s. And the force acting between the two objects is given by these equations. F equals m sub 1, m sub 2 over r squared. R is the distance between the two objects, and the g is a proportional constant. Then let's solve the first practice. The practice 2.1, and suppose you stand on the earth. Compare the gravity of the sun and the earth. The masses of the sun and the earth are 2 times 10 to 33 grams and 6 times 10 to 27 grams. Radius of the earth is 6,000 kilometers. The mean distance between the sun and the earth is 1.5 times 10 to 8 kilometers. The sun, the earth, and we stand on. Then this distance is expressed r sub sun, and this distance is r sub the earth. And the mass of the sun is m sub sun, and the mass of the earth is m sub earth. And the mass of your body is m. The force acting on this object from the sun is F sub sun of the gravity from the earth in F sub the earth. Then F sub sun and F sub the earth is expressed F sub sun is gravitational constant, mass of your bodies, mass of sun over r sub sun squares. And the gravitational force of the earth acting on your bodies is expressed F sub earth g, mass of your bodies, mass of the earth, r sub earth squares. Then we'd like to compare these two forces. When you compare the two variables, it's better to use ratios F sub sun over F sub the earth. Then you can substitute this. Then it becomes m sub sun over m sub the earth times r sub the earth over r sub sun squares. Then you can just substitute all the numbers. It becomes 5 times 10 to minus 4. So this is much smaller than 1. So this means you can find that F sub sun is much smaller than the F sub the earth. So gravitational force from the earth is much stronger than the gravitational force from the sun. So we are strongly bounded by the earth's gravities. Then we'd like to move to the next topic of the Newton's laws. Newton said all the objects follow this Newton's law. First law said bodies remain in a state of rest or uniform motions unless they are acted by a force. So the particles can move with a constant velocities, or particles don't move if there is no force acting on this object. Second law says the force experienced by a bodies is equal to the change of its momentum per unit times. So this says the object, force is acting on this object. Then this means F equal m times accelerations. This is second law. And the third law said if we consider two objects, every action accompanies an equal and opposite reactions. So if this is actions F, then same amount of the force but opposite directions acting on the other object minus F. This is Newton's third laws. So we are going to use this Newton's laws to derive the motion of the planets. Okay, this is the end of this session.